my channel. My name is M.R.E.ngineering and today I'm going to talk about general rules that are used for operation of automotive electrical systems. I know that some guys back off when they face an electrical issue on their cars, and the primary objective of this video is to provide you with simple technical information that reinforces you against a situation that an electrical issue can make you feel embarrassed. Surely you know that automotive electrical systems and electronics are evolving and expanding very fast, and even though in the past electrical system of a car was summarized into ignition system and maybe headlights, but modern cars of today have hundreds of electrical components and a massive amount of wires. And of course, to understand these electrical details, you need to spend a lot of time to pass courses relating to circuits and how transformation of electrical power into movement happens. But I think if you know some laws and scientific facts, you can have a general idea about these electrical systems and the circuits that are used on your car. Generally, when we are talking about electricals and electricity, we are talking about circuits. And if you have a circuit that contains a source of electrical power, you can expect that electricity flows into that circuit. This source of power can produce electrical current in different ways: chemical reaction, magnetic induction, applying pressure, using heat, and even friction. But before I talk about any electrical system or circuit, let me to talk about some scientific facts. What do you know about the atoms? Don't worry, I don't want to talk about rocket science. It's just a tiny little atom. An atom is defined as the smallest part of a chemical element that still has all the characteristics of that element. Okay? Each atom is constructed of electrons and nucleus, and electrons with negative charge are fixed around nucleus with positive charge, and these negative and positive charges attract each other so the atom can retain its balanced state. The critical point here is that the electrical current happens when that source of power forces electrons to move in the circuit. In other words, to have the flow of electrons that is the same as electrical current and electricity, we need to have a demand on the other side so the electrons start to move to that other side. This demand happens when a positive charge on that other side causes a potential difference or a force on the electrons to move. This force in electricity is known as voltage, and its magnitude is expressed in terms of volts. Also, there's a close resemblance between an electrical circuit and a river or creek. Both of them have flow rate. In creek, we have water flow rate, and in electricity, we have electron flow rate. But this flow rate in electricity is known as current and is expressed in terms of amperes. Now, imagine that we put a very big stone in the creek. This action makes a restriction for water flow. This restriction in electricity is known as resistance and is presented in ohms. This resistance can be caused by a dedicated resistor, consumer, or even a back connection in the circuit. But different elements show different electron flow rate when we use them in a circuit with a certain magnitude of voltage. This happens due to different number of electrons in the outer layer of the atoms that is known as valence ring. In fact, the lonely electrons in this outer layer have a loose connection to their atom family, and they get easily detached from that and flow in the circuit. For example, metals like gold, silver, and copper have only one electron in their outer ring and valence ring and easily can lose that one, and they are known as very good conductors. And the iron has two electrons in its outer ring and is known as pretty good conductor, and elements like carbon and silicon have 4 electrons in their outer ring and have a resistance to lose them, and they are known as semiconductors. And materials like rubber and plastics don't let their electrons to go away, and they are known as insulators. Now I want to go from macros to the macros. I think discussion from here would be more sensible for you. In a gasoline car, 2 main sources of electrical power are used: the battery and the alternator, that is an electricity generator. I talk about these components and their functions and characteristics in different and separate videos, but today you just know that battery uses chemical reaction and the alternator uses magnetic induction and rectifier to produce that electromotive force or a DC voltage to have that electrical current or flow of electrons in the circuits. But why two different sources of electrical power are used in a car? The reason is very simple. When the car is off and the alternator is not working, we need to use chemical energy of the battery to start a car. But battery needs to be recharged. So when the car is working using power of the engine and a belt and pulleys, the alternator produces an electricity that its voltage is about 2 volts more than the 12 volts of the battery to recharge that. In fact, it's the alternator that is charging the battery and at the same time supplies power for electrical components and consumers. Also, the battery works as a backup for the alternator, and also it acts as a stabilizer to even out damaging voltage spikes that happen in the circuits on the alternator. And when the car is off, the battery is used to operate accessories and lights. But as I said, the electrons flow from negative side of the connection to the positive side. So we know that electrical current flows from negative side of the battery to the positive side. But based on a conventional theory and the way that technicians think, the electrical current flows from positive side of the battery to the negative side. In fact, it doesn't matter what is the electrical current direction. You just need to know the nature of the current and its effects. In this video, our assumption is that electrical current flows from positive side of the battery to the negative side. In this diagram, you can see a very simple circuit that shows how the alternator and battery are connected to each other and to the loads in a car. The load in this diagram can be a motor, a light, a solenoid, or ignition system, but all of them are designed to use the applied voltage and flow of electrons to do the intended function. For example, an incandescent light diffuses light when it heats up as a result of passing electrons. And also, by reversing polarity of a circuit, we can reverse direction for rotation of a motor. And using this law, we can use a single motor to move the windows of a car up and down. I hope that this video was useful and informative for you and worth the precious time that you spend for watching that. Please subscribe to my channel if you like and press the bell icon to be notified if I have a new video on my channel. Bye.